Hello, second grade. If you are not from my homeroom, my name is Miss Lucklider. I am one of the second grade teachers, and we're going to do a math lesson today where I introduce to you something called the number rack. And here it is right here. Da, 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 da. The number rack in all its glory. This is a math tool that we can use to help us represent numbers, but also to help us add and subtract. So this is a very helpful math tool for second graders. So before I start to show you what we can use this number rack for, I would like you to make a few observations about this number rack, meaning what are some things that you notice about the number rack? And I'll help you get started with some questions. Be thinking about your answers. So what do you notice about the colors of this number rack? What do you see? How many of each color do you see? How many total beads do you see? Do you notice anything special about the top and the bottom? The top row and the bottom row? What do you notice there? Do you notice any patterns maybe? Let's talk about some of those questions and observations and see if your observations match mine. So here are some things that I notice about the number rack. First of all, I notice that there are red beads and there are white beads. Did you notice that too? I bet you did. I also noticed that there are 10 red beads and 10 white beads. And I noticed that pretty quickly because I could see right away that there were 5 red beads on top. 1, 2, 3, 4, 5. And I could see that it matched on the bottom. It lined up perfectly with the beads on the top. So without even counting, I knew if there were 5 on top, then there must also be 5 on bottom. And 5 plus 5 equals 10, that's right. So I noticed that we had 10 red beads, and I can see that we have the same amount of white beads too, because they look exactly the same as this side, only they're white. So if we have 10 red beads, I can see that we also have 10 white beads, because again, I see we have 5 on top and 5 on the bottom. So I know I have 10 of each color, and I can also tell that if I have 10 of each color, 10 plus 10 equals what? How many beads do we have all together in total? That's right, 20 beads, because if we have 10 red and 10 white, 10 plus 10 is 20. So that means all together we have 20 beads on this number rack. So we can represent numbers and do addition and subtraction within 20 on this number rack. Pretty cool, because we do a lot of that in second grade. And not only can I tell that I have 10 red on top, 10 red on bottom, 10 white on top, 10 white on bottom, I can also tell that I have 5 white on top plus 5 red on top, and same thing on the bottom. So not only can I count 10 and 10 equals 20 that way, but I can also count 10 plus 10 equals 20 that way too. So there's 10 beads on top, on the top row, 10 beads on the bottom row. 10 plus 10 is 20. Once again, total of 20 beads. Did you have the same observations that I did? Hopefully so. All right, now let's get into what we can do with this number rack. So I'm going to show you how we can represent numbers using our number rack. So for example, if I were to start with the number 5, if I said, show me 5, if you had one of these in your hand and I said, show me 5 on your number rack, what's one way that you could show me 5? Think about it for a second and then I'll show you what I'm thinking. Maybe you're thinking that you could move these 5 to the left, because actually, let me back up. Before I even get started, it's very important that when you start using a number rack, you always start with your beads pushed as far over to the right as possible. So all my beads are over to the right, because when we want to show or represent a number or give an answer to a math equation, we always want to move that over to the left. So everything we move here is going to be either the number that we're representing or showing or the answer to our equation. Okay, so anything that I'm showing you, I'm going to move to the left. Anything over here is stuff that we're not working with. Okay, so again, if I wanted to show 5, Maybe you thought, well, I could move 5 white beads over to the left. Sure can. That shows 5 right away because I already know there's 5 white beads on top. And notice that I didn't have to go 1, 2, 3, 4, 5. I don't need to do that. Why would I waste my time doing that when I already know that I have 5 right here? If I have 5 right there, I can just start at that last one and say 5, because I already know that's 5. Because that's another thing with the number rack, is you want to always make it your goal to show the number that you're trying to show in as few pushes as possible. So I could move those 5 beads over in 1, 2, 3, 4, 5 swipes, but I don't want to do that because I want to show the number in as few pushes as possible. And the fewest pushes possible right now is just 1 push. Boop. 5 beads over to the left, and that shows 5. I could have also done it on the bottom, and that would have shown 5. I could do 3 on top and 2 on bottom, but again, you want to always do as few pushes as possible. So I could do that, but the smarter choice and the faster choice would be just to do 1 push of 5. What if I wanted to show the number 10? What could I do in the fewest pushes possible? And remember, there's always more than one way to show a number on a number rack too. Well, maybe you're thinking I could push this whole row over to the left, because remember, I already know that there's 5 here and 5 here, and 5 plus 5 is 10. So I know without counting each bead that that's 10 right there. So I could show 10 by pushing this whole top row to the left. Or I could show 10 by pushing this whole bottom row to the left, because I know that there's 10 on the bottom just like there's 10 on top. Or if I wanted to, I could also show 5 and 5. And I have 5 and 5 over here too. This also shows 10, but remember, these aren't the numbers that we're working with. This is the number that we're trying to show. So we're not going to worry about this over here. We're just looking at this. So I could have done it that way too. Now that wouldn't be the fewest pushes possible because that's 2 pushes instead of just 1 push, but that is another way that I could show show 10, because 5 plus 5 is 10. So that's a couple ways I could show 10. What about 9? What could I do? Think about it for a second. What could I do to show 9 in the fewest pushes possible? Well, maybe I could do 5 on top and 4 on bottom. Now, if I know that I have 5 here, I know that 1 less than 5 is 4, or that 4 is 1 less than 5. So then if I just leave 1 white one over here, this should mean that I have 4, right? 1, 2, 3, 4. So rather than counting out 1, 2, 3, 4, I can just leave 1 here, because I know that 4 is, that 4 is 1 less than 5. Yes, that's what I started to say, and then I doubted myself. No, 4 is 1 less than 5. So I could just leave this 1 bead over here and then push these other 4 over to the left, and that would give me 5 plus 4, which is 9. So I could do that. Or I could show my 9 just on 1 row. I could show my 5 white plus 1, 2, 3, 4 red, and that would show 9. And I could do the same thing on the bottom. So that's a few ways to show 9. And again, I can show 9 quickly because I know if I have 10 on top, 1 less than 10 is 9. So if I just leave 1 bead over here, then that should give me 9. And same thing on the bottom. So that's a way I can show 9. Or a few ways I can show 9. What about 7? How could I show 7? Think about what you would do. One way I could show 7 is taking my 5 on my, I'm getting tongue-tied, 5 white on the top, and I know that 5 plus 2 is 7. So I could do 5 white plus 1, 2 red, push it to the left, and that would give me 7. I could do the same thing on the bottom, 5 plus 2 red, and that would give me 7 too. Whoops. Or could do 5 on top, 5 white, and I could do 2 on the bottom. And that would also give me 7. 5 plus 2 is 7. But remember, we want to try to do it in as few pushes as possible. So I could do it in those 2 pushes there, but I could also do it in my quicker way, which is what I showed you the first time. 5 plus 2 on top, or 5 plus 2 on the bottom. But all of those would show 7. What about 3? A much lower number, right? How could I show 3? What would you do? Okay, so I could just count out 1, 2, 3 on top. Or maybe you could think of it even quicker. You know this is 5, and 3 is 2 less than 5. So if you leave 2 white ones, that would be your 2 less. And there's your 3. So you could show 3 that way. You could do the same thing on the bottom. Or maybe you want to do 2 on top and 1 on bottom. Or you can do 1 on top and 2 on bottom. Either one. Now again, that would be 2 pushes as opposed to just 1 push. But all of those ways still work and they still show 3. What about 8? How would you show 8? I'm thinking of a doubles fact. Maybe you're thinking of a doubles fact too. Could we do 4, which I know is 1 less than 5, so if I just leave 1 here, that would be my 1 less. And I could move 4 plus 4, and would that give me 8? Sure would. 4 plus 4 is 8, so that was my doubles fact I was thinking. So I could either do it that way, in 2 pushes, 4 plus 4 is 8, or if I wanted to just do it in 1 push, what would I do? Because the first way I thought of was the doubles fact, just because I know my doubles facts really well. But how could you show it in 1 push? What would you do? Maybe you're thinking you could take 5 of your white, or all of your 5 white on top or bottom, and then 5 plus 3 is 8, so you could do 5 plus 3, 1, 2, 3, and that would give you 8 on top, or you could do the same thing on the bottom and have 8 on the bottom. So that's a few ways you could show 8. Last one before we do one final thing with our number rack today. What about 6? What could you do to show 6? I'm thinking of another doubles fact. Maybe you are too. If you're thinking what I'm thinking, we could do 3 on top. And again, I knew this was 3 quickly because I have 5 white, and I know that 3 is 2 less than 5. So if I leave 2 over here, I can move 3 here. And then 3 on the bottom to show 6, because 3 plus 3 is 6. Was that what you were thinking? Smart cookie. So you could do another doubles fact, and of course that's 2 pushes, but that is one way we could do it, is 3 plus 3 as a doubles fact. But what's another way that we could show 6 with just 1 push? How would you show it in just 1 push? Are you thinking what I'm thinking? We could do 5 plus 1, either on top, 5 white and 1 red, or on the bottom, 5 white and 1 red, because 5 plus 1 is 6. That would just be 1 push. Or if we wanted to go back to 2 pushes, we could do 4 plus 2, right? Or we could do 2 plus 4, so we can flip-flop it, because remember, we can flip-flop parts in addition problems. So those are some ways that we can make 6 as well. All right, my friends, so those are a few examples of how we can use our number rack to represent numbers. One final thing I want to do for this part of our lesson for now, we will have a second part that will go along with the assignment that you have for today. We are going to quickly go through the different ways that we can show 5, or that we can make 5 on our number rack. Let me actually get this uncapped. There we go. All right. So I'm not going to actually show our number rack for this, just because I only have 2 hands and I'm not an octopus. So I can only hold this for right now. But I want you to picture the number rack in your head, the top row and the bottom row. Remember, how many beads are on the top row? 10. And how many beads are on the bottom row? 10. And how many of each color are on top and bottom? There's 10 of each color, but on top there's 5 red, and on top there's 5 white, and on the bottom, 5 red on bottom, 5 white on bottom too, okay? So 5 of each color on top, all right? Get that mental picture in your head, like visualizing in our reading, visualize it in your head for this. All right, we're gonna go through a few ways on how we can make 5 on our number rack using equations. So we're gonna use the top row and the bottom row to equal 5. So I'll get us started with the first way. So if I wanted to show 5 on my number rack, there's quite a few ways I can do that actually. We went through a few of them already. Let's see if we remember. But on our top row, I could move over 5 white and then not move over any on the bottom, which would be 0. And 5 plus 0 is 5. So that's one way we could show 5. I could do the same exact thing, only I would have none on the top. I would keep them all moved over to the right. And I could move my 5 white on the bottom over to the left. And that would give me the same answer. Because remember, in an addition problem, we can flip-flop the 2 parts. 0 plus 5 is the same thing as 5 plus 0. We can flip-flop those 2 parts, and we're still going to get the same answer, the same sum. So that's one way I can, or actually 2 ways I can show 5 on the number rack. If I had 4 on the top row, if I moved over 4 white beads on top, how many would I have to move to the left on the bottom? 4 plus what equals 5? Did you say 1? If you did, you are correct. So I could have 4 on top, 1 on bottom, and that would give me 5. Or remember, I can flip-flop, so same thing. I could have 1 on top plus 4 on the bottom, and that would equal 5. I think I'm already writing too big. I'm gonna have to squeeze. All right, what if I had 3 on top? How many would I need on the bottom to have 5 altogether? 3 plus what is 5? 2. Hopefully you said 2 or thought 2. 3 plus 2 is 5, so 3 on top, 2 on bottom would give us 5. Remember, we can flip-flop, so if we had 2 on top, then we have 3 on the bottom equals 5. Yep, I'm definitely gonna have to squeeze. Sorry, guys. All right, what if I have, oh, wait a minute. Actually, no, I won't, because I think we're done. Yep, so we have 5 on top, 0 on bottom would give us 5. 0 on top, 5 on bottom would give us 5. 4 on top, 1 on bottom would give us 5. 1 on top, 4 on bottom would give us 5. 3 on top, 2 on bottom would give us 5, and 2 on top, 3 on bottom would give us 5. Okay, so look at all those different ways that we can show 5 on our number rack, and that's just with 5. That's kind of a small number. Think about what we could do for much bigger numbers. All right, guys, that is all I have for the number rack right now, but keep all of that in mind for our lesson later today, because we are going to be playing a game with our number rack using everything we just practiced. But stay tuned for part 2 of the lesson for taking a nap on the train. And again, that's going to help you with your activity for this week, or your assignment for this week.